All right, we're gonna pick up on question 3. Just a heads up, by the way, I've been sick the last week, and so I have a bit of the sniffles. So if that's frustrating you, I'm sorry. But just so you know. Okay, so question 3 is a pipeline data path design question. And essentially it gives us some modified or new instructions. In this case, it's called pointer load word and pointer store word. And it asks us a couple of questions about how that would change the pipeline, with both regards to control hazards and data hazards. So this is interesting. It kind of asks us to fill in some code that we'd write if we were like kind of simulating it. Geez, I don't remember this question. Okay, so so pointer load word is a type of instruction which takes the value inside register A. And it does a lookup with respect to the offset, right? So that I think that part of the instruction is pretty standard with what we've seen with like load word, right? However, what is interesting is it takes the value at that address and it does another access. So that value that I just looked up should be an address in it of itself. And so I guess the reason why it's called pointer load word is because that value in memory is a pointer. That value in memory points to something else. And so that this kind of makes sense. And then pointer store word is like the corresponding store for that same type of access. So it says this introduces a structural hazard. Mem1 and Mem2 cannot access data memory. Oh, so we're going to split up our memory into 2 stages. Load and store word access data memory in mem1 and mem2. Pointer load word stores the data from the pointer address in memory. PSW stores the value of reg B to the pointer address in memory. Okay, so sounds like I've split up my memory, and now that introduces some structural hazards. The first code that we're going to write is, it's like bool stall for structural hazard. Essentially, the way I interpret it is this is going to be, should I stall or should I not, right? So it gives us a bit of like example. It says opcode if the opcode inside the IFID instruction is a pointer load word and some other, or a bunch of conditions that we have to fill in, and my guess would be that this would be telling us to look in probably, so the IFID is like kind of identifying which instruction is going to be executed. So then this is probably going to be if there's a conflicting instruction in the next part of the pipeline, right? The first instruction that was executed, because there's 2 kind of instructions involved in the structural hazard. Then we're going to have, then our stall for structural hazards is going to be true, otherwise it's going to be false. So just kind of intuitively, my guess is that all of these are going to be the same. And the reason I say that, I guess I'm not going to write that instruction, but the reason I say that is because, in a structural hazard, if I'm visualizing my pipeline, I'm going to be comparing the 2 stages that matter. So when you did your own simulators for your pipelines, my guess is that many of you wrote some code that was along the lines of, if this opcode for I guess load words, if your opcode was a load word in the would it be IDEX, or I guess if it was not EXMEM and you were in the IDEX, right? You would, if it was a load word and it has a matching register with the register that you have, then you're going to insert a stall, right? So very similar here. This code is structurally going to be similar. And so, I'm going to be comparing what's in the IFID to what's in the next stage, which is going to be the IDEX, right? EX, right? I'm going to look in the IDEX for conflicting instruction. So let's think about what instruction or what sequence of instruction accesses causes this hazard. Well, essentially, it just says I can't access mem1 and mem2 in the same cycle. So the only instructions that access any memory are going to be PLW, PSW, LW, and SW, right? So which one of these ones access mem2, and these ones access mem1. So only instance where I'm going to see this structural hazard is when I am performing an instruction that uses the mem2 access right before I execute instruction that uses the mem1 access. So these mem2 accesses are essentially, this is the first instruction that's going to be executed in the pipeline. So this is going to be PLW or a PSW because both of those instructions use mem2. So we can't perform any access that uses mem1, right? So I shouldn't have circled this. This should be kind of like all of these instructions use mem1. So all of these instructions, if they follow a PLW or PSW, they need to be stalled. And so I'm going to have, a PSW here. I'm going to have an LW and I'm going to have an SW. So that tells me whether I'm going to have a structural hazard resulting from concurrent memory accesses. Awesome. So it says these new instructions also introduce data hazards that require a stall. Cool. Okay. Interesting. This expression should not account for the pre-existing data hazard stall due to LW. So let's think about how this would create a stall. Well, or a data hazard. Okay, so now my pipeline is going to be 6 stages with 2 memory accesses. And so essentially, I'm going to extend this stall, like in load words, right? Even in detect and forward, I had to wait 1 stall, right? Before I could forward the data back because it took that additional cycle for me to go in my EXMEM and perform the lookup. Now with PLW, not only is it going to take me 1 cycle, even in detect and forward, it's going to take me an additional 2 cycles, right? Because I finished my ALU calculation, the solution or like the result of that would be assigned to register B isn't available yet. So then I go perform lookup 1, and then I go perform lookup 2, right? So I have 2 memory accesses or 2 cycles that associated with memory that I need to wait for. So let's see what code they've given us. They said if the opcode in the IDEX register is a PLW and the register A is not 1 and it is and it is equal to register B. So essentially, if I had a PLW instruction, let's write out an example. PLW 3, 4, and then just offset 0. And then I had IFID, remember, comes before IDEX. So we're going to have, let's say, a a PLW, right? Because my IFID instruction has to match my IDEX instruction. Oh, wait, that's not what it's asking. It's asking if register A matches that. Okay, that makes more sense. So then let's say I had like a load instruction, any of the four that, or really any instruction, let's say it's an add, right? And let's say that add instruction, resulted in me doing like 2 plus 3 is equal to, or I guess 2 plus 4 is equal to 5, right? So that's going to be obviously a data hazard. And so in this case, so that's what this example is, right? If the register, oh wait, whoops. So this is what if I had my register B, which is the destination register for my PLW, matches up with the one of the registers that is read by a following instruction, right? So this is obviously going to be a data hazard. So then if I perform so similarly, so it's the other example they give us was what handles kind of this case. If I had an add 2, 4, 3, right? It's going to handle register B, conflict there. So if this was a load instruction, right? This would kind of handle the entirety of it, right? I only have to wait for one cycle. But when I have a longer access pattern, right? I have this PLW, which takes 2 cycles to be forwarded. I have to look not just one instruction forward. I don't just have to look in the IDEX. I have to look even further forward. I have to look in the EX mem, right? So I'm going to have 2 EX mems. So I'm not sure how they want us to refer to that. It looks like there's EX mem, or there's mem1, mem2, so we can refer to it as EX mem1. Okay, so if I had, so essentially I'm gonna have the same logic that I had here, where I compare each of the registers, except I'm not just gonna look in the IDEX, I'm gonna look even further ahead. I'm gonna look 2 cycles ahead. I'm gonna look at the EX mem1. If it's a PLW, right? So now I'm looking even further ahead. I found that, and I'm going to have something, I'm going to have to look at each register. So this will allow me to compare. And so then from there, essentially, I'm just going to copy EA over because I'm comparing the EX mem to the IFID again, right? So I'm going to have here IFID. Here I'm going to have IFID. So here, by the way, I'm not putting instruction there because, or like, I would be looking at like reg A of it. Here I'd be looking at reg A. And then here I'd be looking at reg A, and then here I'd be looking at reg B. Essentially, it's going to be identical to those lines. Here, I'll put it in a different color to emphasize it. Right, it's going to be identical to each of these code segments. But yeah. Awesome. That's all of number 3. I'll see you guys next time for number 4.